To put it simply, exoplanets are planetary bodies that exist outside of our solar system and orbit sun-like stars. Most commonly, exoplanets can take two forms: telluric, smaller dense planets which can potentially support life, and gas giants, which are much larger and are composed of gases only. For example, if aliens from another solar system were to discover Earth in the Milky Way, they would class us as a telluric exoplanet. Exoplanets are important to discover and observe so we can make predictions on how our own planets and solar system are going to change and behave. Some telluric exoplanets could potentially support intelligent life forms. For an exoplanet to support life, it must exist in the habitable zone in its respective solar system. This zone is a region of space around the Sun-like star in which the atmospheric pressure of the planet can support liquid water on its surface. This zone is known as the Goldilocks zone, as the conditions are just right to support life. The Goldilocks zone is calculated for each star using the known atmospheric pressure and conditions on Earth and the position of exoplanets in relation to the Sun-like star at the center of the solar system. Discovering exoplanets is extremely difficult as they can exist up to huge distances away. NASA uses a range of ingenious techniques to uncover exoplanets that would be impossible to find using a satellite. Astrometry is the simplest way to discover exoplanets. It involves plotting the precise movements and positions of the planetary bodies in the sky and observing them change. Exoplanets can be discovered this way when the observed patterns of planets change. This change in position is caused by the gravitational pull of another smaller star, such as a telluric exoplanet, which may be nearby. Polarimetry is a method used to distinguish the composition of the atmosphere on another planet. This technique works because light reflected from stars is unpolarized, but light reflected from planets with atmospheres is partially polarized. This is because light waves entering the atmosphere of a planet are polarized by the molecules in its atmosphere. Light returning from a planetary body is therefore partially polarized. The extent to which it is polarized depends on the atmosphere, which is how astronomers can make predictions on the composition of the planet. Doppler spectroscopy is the technique used by the NASA Kepler satellite to detect exoplanets in the different constellations. It works by measuring the variation in the observed speed of orbit of a planetary body, caused by the Doppler effect. The technique just mentioned is carried out by measuring the light spectrum emitted by a planetary body. Because of the Doppler effect, the spectrum fluctuates. By using a statistical analysis, astronomers such as NASA can remove sources of uncertainty that could affect the spectrum and isolate a sine wave from the spectrum observations.